Morning. No reply. Okay. First, am I audible? 7. Okay, the same person is saying for the 7th question. I thought what they given in the 7th question. Audible. Okay. So 7th question is what? I think what it was the track 1 or track 2? Which question? Just give the idea. Who is asking this 7th question? No problem. Can you starting? Can you say? Who is asking the 7th question? Can you say what is that starting question? Then I will get to know that which question you are asking. Because in the study already the student has asked. Sir, lower than 11 into 10. So that question, what? I think 20 degree C, length of the rod given what? L is equal to, I think, 1 meter. Length of the rod given 1 meter. And then it asks if the temperature at 19 degree C. At 19 degree C, theta 2 given what? 19 degree C, theta 1 is a 20 degree C. Exactly 10 centimeter. Length, okay. So length has given 10 centimeter. So theta 1 20 degree C, theta 2 19 degree C means from 20 degree C to that 19 degree C temperature we are decreasing. It means what is the delta theta? Delta theta is 1 degree C. Actual original length is what? 10 centimeter. Then our question was what? Longer, shorter. Longer, shorter means not the final length. Means 10 centimeter is the natural length. Okay. Then what will happen? When we will decrease the temperature, 20 to the 19, it means how much temperature decrease? 1 degree C. Then delta L, we can say what? Delta L will be equal to L alpha delta theta. Delta theta you will take 1, alpha given in the problem, and L you will take the 0.1. After that, whatever you are getting, the length will decrease. It will get shorter by this length. It will get shorter by the delta L. So the final length is not asking how much shorter, how much longer. So temperature we are decreasing, then length will decrease. How much decrease? So it will become shorter by delta L, and delta L value you have to find. Understood or not? Please say fast. So the question meaning maybe you have not. You have, if I'm saying it becomes shorten up to, it shorten up to means final. Okay, shorter by, then it means what? How much decrease? Getting or not? Okay, second question means that iron tire question. Iron tire question means wheel diameter. Wheel diameter is given, I think, 1 meter given. Wheel diameter is given 1 meter, and then iron tire diameter is 6 millimeter shorter. They are also the same meaning. Means delta D for the tire is 6 millimeter. They have not given the diameter of the tire. Diameter of the tire is the 6 millimeter. It is the given diameter of the wheel. Diameter of the wheel is 1 meter. And then diameter of the tire is 6 millimeter shorter. Means it is a 6 millimeter smaller than 6 millimeter smaller than the what? Wheel. It means if I'm saying what is the diameter of the tire, then you will say 1 minus 0.006. It will come 0.994. That is the diameter of the tire. 6 millimeter shorter given. They have not given the diameter of the tire is a 6 millimeter. Everybody getting or not? So here also delta T is what? 6 millimeter. Now they are saying up to what temperature we have to heat it so that it will get fitted on the wheel. So delta T is the 6 millimeter means 6 into 10 to the power minus 3. D what you will take? initial diameter of the tire is 0.994. But what I said in the last class, right hand side approximation we can use 0.994, we can take as a 1. So delta D is the 6 into 10 to the power minus 3. D is D what you will take 1, alpha already given. From that you will find the delta theta. After finding the delta theta is what? Theta final minus theta initial. Initial given, final you can find. Tanuj, understood or not? They say fast. So that's why I said a small word will change the meaning of the question. Increase by, increase to. Okay, all these things we have to read carefully, because otherwise everything you know, but due to the you are not understanding the question properly, so everything you will do wrong. Why? You are reading the question in hurry. Question we have to read slowly. Answer we have to do fast. Okay. Completed. Okay, so last class I completed the calibration temperature. Last class I completed the calibration temperature. L observed formula L naught into 1 plus alpha or R means scale will have the effect of the temperature. That concept completed. Tell fast. Say someone, yes sir, completed. Means one question I discussed, steel rod, steel tape, okay, area and volume expansion completed, okay. So a small question of the volume and area expansion. Now listen carefully, immediately you will give the answer, okay. Anisotropic till completed, okay. Question I discussed, 1-2 question also I discussed in the volume expansion, okay. Now listen. If I am saying I have the one solid sphere and one hollow sphere, okay, solid sphere and hollow sphere. Sphere of same material. Okay. So we have the solid sphere and hollow sphere of the same material. Their temperature means their temperature we increase by the same amount. We increase the temperature by same amount. Now, who you have to say whose change in volume will be more? Whose change in volume will be more? Again, I am saying solid sphere and the hollow sphere of same material and same radius. Also, I am giving same material and same radius. We have the solid sphere and hollow sphere. Then, if I am increasing their temperature by the same amount, whose volume change will be more? Same, I guess. Okay. Somebody is saying the answer same, I guess. Okay. Same, sir. So same. Reason is what? Delta V. What is the formula of the delta V? Delta V is the V initial into gamma into delta theta. Means change in volume depends upon these factors. Change in temperature, material and the initial volume. Solid hollow doesn't matter. Ultimately radius is same. Radius is same. It means their initial volume is same. Okay. Means Vi is same. Gamma, I gave the same material, means gamma is also same. Okay. Now I gave the same rise in temperature, means delta theta same. Then we can say what? Volume change will be same. So delta V also same. But suppose the same question in Sunday question, that paper was not there. That question was not there. That is a disk paper I gave only. So disk and the hole was there. For that radius I asked. But the solid and hollow sphere, the question was not there. Which institute paper? That is also one thing. Okay. Second question. Okay. Second similar question. If I am saying the both has the same mass. Okay. both sphere has the same mass, and then rest of the thing is same, material same, change in temperature same, but they have the same mass, then whose volume change will be more, or what will be the relation between the volume change? If their masses are same, okay, no problem. Okay, so if their masses are same, then what will happen? Whose change in volume will be more, or they will have the equal change in volume? If their masses are same, material same, masses same, change in temperature same. Same, okay. Most of the students are giving the answer same, okay. In that case, listen now. Any paper? Suppose I am giving the equal amount of material. Suppose this is the material, okay, copper or something. I'm giving you, and I'm saying both masses are same. Okay, like 50 gram, 50 gram. I'm giving the copper. Okay, I'm saying you will make the solid sphere from this one. You will make the solid sphere. One you will make the hollow sphere. Okay. So solid sphere, how you make? You got the material, now you make the laddu, okay? So then it becomes the solid sphere, okay? In hollow sphere, whole mass you will put on the circumference. So when you are putting, you can think like you are taking any balloon, on the balloon you are pasting the big balloon, on that you are pasting the mass, material, okay, on the circumference only. So by using your common sense, you will say, which material, which sphere will have the more volume, or which sphere will have the more radius? One is the solid, I make the solid ball, okay, and one I make the hollow sphere. Which will have the more radius, hollow or solid? If I am giving the mass same, material we have to use same. Hollow. Hollow, okay, good. Hollow. Hollow will have, because hollow has a mass only on the boundary. Hollow has the mass only on the circumference, okay? But solid means from the inside to the outside mass will be there. So size of the hollow will be more. Now initial size means initial radius more. So gamma and delta theta. Gamma and delta theta same because material I gave same, delta theta I gave same. But initial volume will be more. Initial volume will be more for the hollow sphere. So who will, delta V will be more for hollow sphere because initial size is more. Are everybody got? So hollow sphere, delta V will be more. Understood or not? So if I gave the initial size is same, initial size same, material same, delta theta same, then we will say the elongation, the expansion will be same because delta V formula we have to think. Now, if I am giving the mass same, so first we have to decide size will be same or not. No, size will not be same. Hollow will have the bigger size. Now, initial size of the hollow is more, then ultimately what will happen? Its change in volume will be more. Everybody got? Okay. Up to this, okay? So one question I discussed the delta V, like a sphere I gave, then I asked what is the delta V for that. Okay. Another railway track question I discussed. Railway track question. No, okay. So suppose I am giving a gap of 1 centimeter is in between two rail track, each of length 20 meter. At 10 degree C. Then find the temperature at which gap get filled. Alpha of iron is equal to, suppose simple calculation, I am giving 10 to the power minus 5 degree C. So here what I gave, a gap of 1 centimeter is between the two rail track. Everybody got? Okay, so two rail track we have. In that we have the gap of what? 1 centimeter. We have the gap of 1 centimeter. Everybody know that in the railway track, if you have seen, there is a gap. Now why we make the gap? Because in the summer the track will get expand. So if the gap is not there, I think this I discuss also. If the gap is not there, then what will happen? It will bend like the bimetallic strip. Okay, so we are making the gap between the each track so that in the summer when the temperature more or due to the continuous use when it is getting heated, then after expansion it will fill the gap, but it will not get deformed. Okay, so here what I gave at 10 degree C, what is the gap I gave? Like this is the railway track. Okay, and what is the gap between them? 1 centimeter I gave. At 10 degree C, I gave the gap is 1 centimeter. Now I am saying at which temperature, at what temperature the gap will get filled, means both track will touch each other. At which temperature both track will touch each other. Tell fast what you will do. Alpha value I gave 10 to the power minus 5. Anybody? So listen. Now I am saying the different options. You will say okay, which you will take. So somebody is taking the change to fill the gap. How much expansion required? Delta L required is 1 centimeter. Okay. So somebody will do what? Delta L they will take 1 centimeter. Delta L is 1 centimeter. And the length of the each track I gave 20 centimeter. Length of each track is 20 meter. Length of each track is 20 meter. Okay. So delta L you have taken 1 centimeter. Okay. Length of each track you took 20 meter. Centimeter you will convert in meter. So delta L is equal to L. Alpha already given, you will find delta theta. Okay, delta theta will be theta final minus theta initial. Initial is 10. From that we will get the final temperature. How many of you will do that? I am saying delta L you will take, because gap is what? 1 centimeter. To fill the gap of 1 centimeter, they have to expand 1 centimeter. So delta L what you will take? 1 centimeter. Okay. L what you will take? L you will take 20 meter. Okay. Alpha already given, delta theta we will find. After finding the delta theta is the theta final minus theta initial. Who will do that? This is correct or not? Tell fast. It is correct or not? Calculation and all I will do, no problem. Wrong, sir. Very good. 510. What is this 510? No, sir. Yes, sir. Correct, sir. 510. 510 or 51? What you are writing? Correct, sir. Okay. Yes, sir. Correct, sir. No, sir. Okay. $60. Both? Okay. Now second solution I am saying. Okay, somebody is saying this is correct. Somebody is saying because who will say this solution? They are only focusing on the data. Data means they are saying okay, gap is the delta L is what 1 centimeter. Okay, gap is 1 centimeter, so delta L I will take 1 centimeter. L is what given 20 meter, and then alpha and delta theta I will find. Okay. Somebody will think more. Then what they will say? Okay. Here gap is 1 centimeter between the two track, but both track will expand. So each track has to expand 0.5 centimeter. Okay, somebody will think more. They will say what? Here gap is 1 centimeter. Then to fill the gap, both will expand. No? So both will expand means it will expand 0.5. It will expand 0.5. Then the gap will get filled. So then you will take the delta L is equal to 0.5 centimeter. After that L is the 20, alpha is the same, delta theta you will find. How many of you will say this is correct? They will take delta L is equal to 0.5. 0.5. Delta L is a 0.5 centimeter. How many of you will take that? Tell fast. Delta L is equal to 0.5 because the both track will expand, so 0.5 each has to expand, and then the gap will get filled. Okay, 1, 2 member, 3 member. Okay, anybody saying this is wrong? This is the only problem in the online, means we cannot in the class, then I can get the different answers also. Okay, but it takes time in the online. Correct? Okay, correct. Okay, now listen. Sometime in the exam what happened, somebody don't think more, so mistake upon mistake get cancelled out and they get the right answer. Okay, so this second method, who got the second answer from the second method, they think little more than the first case. Okay, but you know what is the right answer? Right answer we will get from the first one. Why? So first one who thought that only, so their thinking is wrong, but fortunately they are getting the right answer. Who think the second one, they'll think little. Okay, little more than the first one, but what they miss, track is what? To fill the gap, track will expand, each track will expand 0.5, but track will not only expand in one direction, na? Track will expand in the other direction also, because here also track will be there. Okay, so if you are focusing on the middle track, so middle track will expand here 0.5, here also 0.5, na? So ultimately each track will expand what? Each track will expand 1 centimeter. So who has not think this much, they only taken the focusing on the data only, they got the right answer. Who think the little more means, okay, each will expand 0.5, what they miss, everybody got or not? Because that will not expand in a one direction only, it will expand in the other direction also. So in elongation in each track is what? 0.5 here, 0.5 here. So what is the elongation in each track? 1 centimeter. So delta L what you will take? Ultimately delta L for each track. Delta L is equal to 1 centimeter, or I can say what? 10 to the power minus 2 meter. Everybody got or not? So now you can think, na, who is think little, they lost. Who has not think directly, they focus on. So sometime it happened in the exam. Okay, so delta L and length we will take what? 20 meter. Now after putting in the formula, delta L is equal to L alpha delta theta. L value 10 to the power minus 2. L is the 20. Alpha is the 10 to the power minus 5. From this delta theta you will calculate. How much you got? That is a 1000 by 20 means 100 by 2 means 50. Delta theta is 50. Delta theta is 50 degrees C. Now delta theta we can say theta final minus theta initial is equal to 50. Initial given what? 10 degrees C. 10 or 20? 20. 10. So theta final will come 60, na? Vardhan. So theta final will come what? 60 degrees C. Everybody got? Completed? Okay. Up to this, okay? Okay. One question of the calibration temperature that is based on the clock problem, pendulum clock problem, that I will discuss when I will discuss the unit and dimension, because some concept of the fractional change, this we are using from the unit and dimension. So clock problem right now I am not discussing. In the unit time, after completing the unit dimension or in the unit dimension, there I will discuss. Okay. Now next is so everybody know when we increase the temperature, most of the solid, we are always taking what? On increasing the temperature, volume will increase. So on increasing the temperature of the solid, okay, volume increases. Thermal expansion, we have learned the volume change formula also. Okay, so on increasing the temperature, volume increases. Volume increases. What about mass? What will happen with the mass? If we increase the temperature of any body, then what will be the effect on the mass? Mass decreases, constant. Mass will remain constant, nalaye. Mass, why mass will change? Ultimately, same number of particles are there. Volume increases, why particles are going far. So that's why volume increases. But mass does not change. Otherwise, mass will change by heating. Then buy the gold, 1 kg gold, heat it. It will become one extra 100 gram, 10 gram, whatever it will increase. Then after that, again, you can sell. Okay. So mass does not change. Mass does not change. Volume changes. So on increasing the temperature, volume increases. Mass does not change. Then what will be the effect on the density? Then what will be the effect on density? Tell fast. What is the effect on the density? No change. Density, no change. Density decreases. Okay. Density decreases. Reason is what? Mass is equal to volume into density. Now volume on increasing temperature, what we can say, volume increases, then but mass remain constant. Mass is constant, so density decreases. Okay, why? Earlier, suppose before heating, the molecule are at some distance, atoms are at some distance. When you are increasing the temperature, they are going far. So means we can say molecular density is decreasing, means they are going far. So that's why same number of molecules, they are occupying the more volume. They are in the more volume, so we can say density decreases. So everybody got the effect of temperature on the volume, mass and density. Okay, now if I am saying mass is equal to volume into density, here both volume and density are changing. Both volume and density are changing, but mass does not change. Okay, I want to find the change in the volume and density. Okay, mass is equal to volume into density. We know that on increasing or on changing the temperature, volume and density is changing, but mass does not change. To get the change, what we are doing, like in any function, to get the change, we are differentiating. Okay, so what we will do, we will differentiate in left hand side and right hand side. Who will say what is the differentiation of m? What is the differentiation of m? What is the differentiation of m? Delta m. Very good. Okay, dm. Okay, but what is a dm? What is a dm? 0. Why 0? Because mass is constant. Mass differentiation of x is dx. I said we will differentiate in the both side, left hand side and right hand side. So mass differentiation is that x differentiation is dx. Mass differentiation is dm, but mass is constant. Mass does not change, so dm will be what? Change in the mass. Delta means change in the mass. Change in the mass is what? 0. So dm, what I can say? 0. So differentiation of mass will be 0. Okay. Now, right hand side, we have the two function, volume and density. Volume and density. We will use the product rule. Product rule is what? First function into second differentiation plus second function into first differentiation. Product rule. First into second differentiation plus second into first differentiation. Then what you will get? V into d rho is equal to minus rho into dv. Rho into dv. Then what we got? Then we can say rho one side. So d rho by rho is equal to minus dv by v. Okay. This relation everybody understood? Tell fast. This relation everybody got? Okay. Now delta rho by rho. Delta rho by rho, what we can say? Minus delta v by v. Minus delta v by v. Okay. And delta v by v, already we learned the formula. Delta v by v is equal to gamma delta theta. Gamma delta theta. So this I can say what? Minus gamma delta theta. This relation you have to remember. Now listen. Delta rho by rho is the fractional change in density. Fractional change in density. Delta v by v, fractional change in volume. Okay, fractional change in volume formula, we know that gamma into delta theta. What minus sign indicates here? Why we are getting the minus sign in this relation? So we know that on increasing the temperature, volume increases. If the volume increases, so density will decrease. So if the delta V is positive, then delta rho will be negative. If delta V is negative, then delta rho will be positive. Suppose we are decreasing the temperature. When we are decreasing the temperature, then delta V will be negative. Delta V will be negative. When we are decreasing the temperature, then what will happen? Delta theta negative, so delta V will be negative. It is negative and already minus sign is there. So negative and negative will become positive. So delta rho by rho will be positive. So when the temperature increase, volume increases, density decreases. When temperature decrease, then volume decreases or density increases. This everybody got or not? Tell fast. And their fractional change will be same. Fractional change or percentage change, magnitude will be same. Like suppose I am saying on increasing the temperature, volume increases by 4%. On increasing the temperature, volume increases by 4%. On increasing the temperature, volume increases by 4%. What is the percentage change in density? On increasing the temperature, suppose on increasing temperature, volume increases by 4%. Then find percentage change in density. Tell fast. Then find percentage change in the density. decrease by 4. Decrease by 4. We will say decrease by 4. So magnitude is same, but one is increasing, so other will decrease. So we will say what? Decrease by delta rho by rho into 100. That will be equal to minus 4%. Or we can say decrease by 4%. Up to this, everybody got? Okay. Okay. Density relation, whatever I am saying in the solid, same we will apply for the liquid also. So the reason is what? On increasing the temperature of the liquid also, mass does not change, volume increases, so density decreases. So whatever density relation I am discussing in solid, same we will apply for the liquid also. Okay. Another thing, now I got fractional change in the density. Fractional change in density will be delta rho by rho. That will come what? Minus gamma delta theta. This everybody got? So fractional change in the density will be delta rho by rho. That will be equal to minus gamma delta theta. This everybody understood or not? If magnitude only they are giving, it means like no negative answer they are giving, it means they are asking the magnitude. Then directly we will go gamma delta theta. Okay. Up to this everybody got? So delta rho, what I can write? Delta rho I can write minus rho gamma delta theta. Minus rho gamma delta theta. Okay. Then up to this, okay. So if I am saying what is the final density? So final density I can say what? Initial density plus delta rho. Then from this final density what I will get? If I am putting the rho value here, rho minus rho gamma delta theta, then rho final what you will get? Rho common into 1 minus gamma delta theta. Okay, so what is the final density? I can say initial density into 1 minus gamma delta theta. Same formula like a volume final, but only in the case of the final volume we are getting the plus in between. Here we are getting minus in between. Delta theta positive, then density decreases because the in between minus is there. If delta theta negative means temperature is decreasing, so delta theta will be negative. When it is a negative, already negative sign is there, then final density will be more. So on increasing the temperature, density decreases. On decreasing the temperature, density increases. Everybody got? Up to this, okay? Now one more thing, listen. Basically, V final is equal to V initial into 1 plus gamma delta theta. We got by using the thermal expansion. Okay. Sometime, listen carefully. This formula we have to remember, and in the NCERT only one question given on the density, that is a fractional change in the density they are asking. Okay. Then there is a no problem. Delta rho by rho is the minus gamma delta theta. Minus gamma delta theta. Some question, symbol question, then there is only problem. When the question they are using the rho 1 is the density at theta 1, rho 2 is the density at theta 2. So sometime what will happen? Your answer will not match by this formula. Maybe they will give the option, so that is not matching with this formula. Okay. So another relation we can also use. Suppose I am saying we know that mass is equal to, or density is equal to mass by volume. Density is equal to mass by volume. Yes or no? What I'm saying, numerical problem, no numerical question, no problem. Directly we can use the rho final is equal to rho initial into 1 minus gamma delta theta. Gamma will be very small, that's why it will give the correct reading. Okay. Or mainly they will ask the delta rho by rho, no problem, that is a minus gamma delta theta. But suppose in some symbol question at temperature T1, density rho 1, temperature T2, density rho 2, then what will be the gamma? Any question like that they are asking. And question answers options given in symbol rho 1, rho 2, T1, T2. Suppose you are not getting the any option by using the first formula. What I said, rho final is the rho initial into 1 minus gamma delta theta. Then check the option by using this, what I'm going to say. Rho is equal to mass by volume. Everybody know or not? Yes. Now, on increasing the temperature, rho final, I can say what? Mass does not change. Mass does not change. V final, I can say V final is the V initial into 1 plus gamma delta theta. This everybody got or not? Rho initial and this initial I will write. When final I am saying, so I will take the volume final. This both relation everybody understood? Okay, now M upon VI what I can use? So rho final, what we will get? Rho final is the rho initial in upon 1 plus gamma delta theta. Basically, this formula and the previous formula, what I said for the rho final, both are the nearly similar. Why? Because gamma delta theta is small. If I'm using the binomial approximation, I can shift it up. So rho final, I can say what? Rho initial into 1 plus gamma delta theta whole to the power minus 1. And I can use 1 plus nx, so rho final is equal to rho initial into 1 minus gamma delta theta. So basically I got the same formula or not? So these two you have to remember. In the numerical problem, you can go to the rho final is equal to rho initial into 1 minus gamma delta theta. Delta theta, temperature increase, delta theta positive, temperature decrease, delta theta negative. Okay, but any simple question, suppose you are not getting the any option by using the second formula, then you can go to check for the above formula. Rho final is equal to rho initial. Small variation will come in the symbol. Okay, rho final is equal to rho initial upon 1 plus gamma delta theta. Everybody got? Tell fast. Understood? So for the density, we have to remember the two formula. Okay, completed. So same formula I will use right now. Question I am not discussing here. Question I will discuss in the liquid by using the same formula. Okay, up to this okay. Now last thing in the solid, I already said in the when I discuss about the alpha, so I said theoretical question if they are saying value of the alpha depends upon. So if we have to select the one option, then we will select the material. But more appropriate option is what? Material and its temperature. Why? As temperature changes, material property changes, so alpha or gamma of the solid changes. Okay. So in NCERT one graph has given that already they asked in the 2016. Okay. So variation of the alpha or gamma they given with the temperature. So one graph that they given, it shows what gamma of the material or solid changes with change in temperature. Okay. So that graph you have to keep in the mind. That given graph is given for copper. Okay, for copper they given that graph, and graph is like this. So it is the material property, so we cannot say all material will follow the same graph. All material will follow the same graph, but this graph shows the variation. Means by this graph we can at least we can say as the temperature is changing, gamma is not constant. So this graph shows the variation that solid gamma will not constant, it will change with the change in temperature. Okay, so this graph only shows the variation, but I cannot say for every material that we will get the same graph. Understood or not? So this graph just you have to keep in the mind. Completed? Okay. Up to this okay? And by the graph for this copper particularly, I can say I have mentioned the temperature here 500 Kelvin. So at high temperature it is almost constant. At high temperature it is almost constant. But in the beginning, as the temperature is increasing, variation is more. Okay, but after the 500 Kelvin, graph is almost like a straight line parallel to the y-axis, means almost constant. So at high temperature it is almost constant by this graph. But this shows what gamma will not be constant for the solid. It will change with the change in material. Completed. Okay. Thermal expansion of liquid. Okay, now solid completed. Everybody got about the solid. Okay, few question means little bit lengthy question that we will discuss later. Otherwise, in the test you will get. So which material you are solving, module at least you have to solve. Okay. Now listen, liquid, if I am saying for the liquid, what is the relation between alpha, beta and gamma? Anybody can say, or you learn, what is the relation between the alpha, beta and gamma for the liquid? What is the relation between alpha, beta and gamma for the liquid? Anybody learn any relation? Relation between alpha, beta and gamma for the liquid. Don't know, sir. Good answer. Okay. No, sir. Don't remember, sir. Okay, means you read but you don't remember. Okay, good. Now listen. Alpha and beta, that is not defined for the liquid. Alpha and beta is not defined for the liquid. If I'm saying what is the length of the water, what is the length of the gas, okay, hint, now I am explaining only. Now, not hint, I am explaining only. What I am saying, for liquid and gases, gas, suppose in the room air is there, can I say what is the length of the gas? So for liquid and the gases, we cannot define the length and the area. We cannot define. For liquid and when we are buying the gas cylinder, we are not buying the length of the cylinder. Give the 5-meter gas. Okay, what we are saying, give this meter cube or centimeter cube, cc, meter cube, liter. Okay, when we are buying the milk, we are not saying give the 5 meters of milk. Okay, so liquid and gases, length and area is not defined. Now, that is not a unique, we can say. So for liquid and gases, we are only defining the volume expansion. Volume expansion means we are only defining the gamma for the liquid and gases. Okay, so there is no meaning of the relation between the alpha, beta and gamma for the liquid. What we are using, because so many times it happened in the apparent expansion problem and the real expansion problem, people will use the gamma is equal to 3 alpha for the liquid. That's why in the beginning I asked. Okay, so for the liquid we are not defining alpha and beta. For the liquid and gases we are only defining the coefficient of volume expansion, or we are defining volume expansion. Everybody got? So there is no meaning of the relation between the alpha, beta, gamma in the case of liquid and gas. Alpha is to beta is to gamma is the 1 is to 2 is to 3. We are using for the solids only, and that is particularly for the isotropic solid. Everybody got? Okay, up to this okay? Okay, now in the liquid one more problem is there. In liquid, suppose I want to heat the liquid. Suppose I am saying heat the water. So water I cannot put on the gas directly and then water will get heated. If I want to heat the water, then I have to put the water in some container and then I have to put on the gas. Okay, so water or any liquid we cannot heat it directly. Okay, so to heat it, first we have to put the liquid in the container and then we will heat. It means container will get heated as well as liquid will get heated. Everybody getting or not? So that's why in the case of the liquid, we learn the two expansion. One is the real expansion, one is the apparent expansion. In case of liquid, why? Because liquid we cannot heat it directly. Okay, we will heat the liquid by putting on the putting in the container. That is a different case. Suppose you have the lake. In that lake, you are like surrounding temperature decrease. Then there we will not consider the expansion of the lake volume. In that case, we cannot say. But like if I want to heat some liquid, I will put in the container. Then in the liquid, we are defining the two expansion. One is the real expansion. One is the apparent expansion. This everybody got? Up to this, okay? Okay. Now suppose one is small example I am taking. I took the 500 ml of the water, and in the container whose capacity is 500 ml. I took the 500 ml water in the container of the capacity 500 ml. Okay. Now I start heating this container and the liquid. Okay. After raising some temperature, suppose I am saying container is solid will also expand. It will have the different value of some alpha value, gamma value, beta value. So solid container is a solid, container will also expand. Liquid will also expand. Okay, suppose I am saying container expand by 5 ml, container expand by 5 ml and liquid expand by 9 ml. Liquid expand by 9 ml and the container is solid, so generally container expand less, liquid expand more. So I gave the data. Suppose container expanded by 5 ml and the liquid expanded by 9 ml. Okay, what you will observe? Tell fast. If this happened after passing the gas, after heating it, what happened? Liquid expanded by 9 ml and the container expanded by 5 ml. What you will observe after heating? Tell fast. After heating, what you will observe? After heating, what you will observe? Tell fast. Water will both expanded, that is okay. Both expanded, that already I gave the values, means container expanded by 5 ml and the liquid expanded by 9 ml. Then after that, what will happen? Now listen, container liquid will overflow because completely filled. Now container created the extra, by the expansion of container, extra 5 ml space created, volume created. By the expansion of container, 5 ml extra volume created. But the liquid expanded by 9 ml. So 5 ml extra container will fill by the extra 5 ml liquid. Okay. But still the 4 ml liquid will remain. So what will happen? Now that there is no place in the container, so 4 ml liquid will come out. It means 4 ml liquid will overflow. This everybody got or not? Whatever data I gave, according to that data, what I can say, 5 ml means 5 ml container expand, 9 ml liquid expand. So extra 4 ml of the liquid will come out because place will not be there, or space will not be there in the container. Okay, so what we will observe? By seeing the container, can you say container expanded by 5 ml? By seeing the container, we cannot say, directly by seeing the container expanded. This much of expansion will not be there. So by seeing the container, we cannot get the idea about the expansion of container. But what we will see what? Container liquid came out. So what we will say? We will say what? On heating the liquid expanded, so that liquid overflow. What we will observe, according to that we will say, So 4 ml liquid came out. So we will see that some liquid came out. So what explanation we will give? On heating the liquid expanded, so that liquid overflown. Whatever came out, if you measure the volume in the measuring flask, you will get the 4 ml. So you will say liquid expanded by 4 ml. What came out, that you measure the volume of that, and suppose you got the 4 ml. So you will say the liquid expanded by 4 ml. But actually liquid expanded by 4 ml? No, liquid expanded by 9 ml. But what we can see the 4 ml only. So it means what expansion we observe, that is called the apparent expansion. Okay, so apparent expansion means what? The expansion what we observe. Okay, what is a real expansion? It is a real expansion mean actual expansion of the liquid. That is what according to this data 9 ml. Okay, so two things are there. One is the apparent expansion that we observe. Observed expansion is the apparent expansion. According to the given data, it will be 4 ml. And the real expansion means how much actually the liquid expanded. To measure this real expansion, whole liquid you will put in the measuring flask. When you put in the measuring flask, you will get what? 509 ml. If you put the whole, just take out of the container and put in the measuring flask. In the measuring flask, you got the volume is 509 ml. 509 ml, then you will get to know. Initially, I took 500. Now it is a 509. It means 9 ml extra liquid expanded. So real expansion, you will say 9 ml. But what we observe directly, that is the apparent expansion. It will be 4 ml. Everybody got or not? Okay. Are say fast. Everybody understood or not? What is the meaning of real expansion and apparent expansion? Why we are learning this real and apparent expansion? So in liquid, we are defining number one. So what is the apparent volume expansion? It is observed expansion of liquid. Okay, after changing temperature. Now, who will say this apparent expansion depends upon the liquid only, or it depends upon the liquid as well as container? This apparent expansion depends upon the liquid only or liquid as well as container? This apparent expansion depends upon the liquid only or liquid as well as container? Both. Yeah, because why? Suppose container, what I said here, container expanded by 5 ml, liquid expanded by 9 ml. What is the expansion in apparent expansion? I said 4 ml. If the container expanded by 6 ml, then how much will come out? 3 ml. If the container expanded by 7 ml, then how much will come out? 2 ml. It means apparent expansion depends upon the liquid as well as container. Okay. So it depends upon liquid as well as container. This everybody got? Okay. Up to this, okay? So it is an observed expansion. It depends upon the liquid as well as container. Now, if I am defining the gamma apparent. So gamma apparent, what I can say? Delta V observed upon V initial into delta theta. Okay, what is the gamma apparent formula? Gamma apparent, we can say delta V observed upon V initial into delta theta. Like gamma formula is the delta V by V initial into delta theta. Now apparent, if I am defining, so which delta V I will take? Observed delta V upon V initial into delta theta. Everybody got? And it will be different in different container. Everybody got up to this? Now number 2 is the real expansion. So real expansion means it is the property of liquid only. Okay, here it will not depends upon the container. If I am saying any liquid like water, kerosene, glycerine, so real expansion is the property of liquid. Apparent expansion will change with the change in the container. But if I am changing the temperature of any particular liquid, suppose milk we are boiling in a steel container or we are boiling in iron container, if the temperature of the milk increase by 100 degrees C, then if the same amount I took in the both container, then ultimately delta V real will be same. Observed will be different, maybe steel container different, copper container different. But if I'm taking the same amount of milk in the copper container and the steel container and I increase the temperature of the milk by the same amount, so actual expansion in the milk will be same in both container, but apparent expansion will be different in different container. Everybody got? So it depends upon liquid. And does not depends upon okay. So we can say what? For given liquid, with gamma real is constant. Okay, so apparent will change with the change in container, but for the given liquid, gamma real we can take constant. Okay, now gamma real, how we can define? Gamma real will be equal to what? Delta V actual upon V initial into delta theta. Similar formula, only in the numerator we have to take the actual expansion. Up to this everybody got? Like what example I discussed, then if I'm asking gamma apparent, then gamma apparent I will define 4 ml overflow, then I will take delta V observed is the 4 ml, initial volume what I give 500 ml, delta theta whatever I will give. Okay, real expansion what I will define, what is actual expansion 9 ml, what is the initial volume 500 and delta theta according to the given value. Okay. So suppose I gave in the problem gamma of the water is this, gamma of the water is this, gamma of the glycerine is this. If I have not mentioned, means I am only saying gamma of the liquid. So gamma of the liquid means which gamma I gave, real or apparent? If I am saying gamma of the liquid is this, so which gamma I gave, real or apparent? Gamma real, because apparent will be different in the different container, then why I will because then for apparent I will mention the container, means gamma of the water in the steel container, it means it is a gamma apparent in the steel container. Okay, but if only I am saying gamma of the liquid, it means it is a real gamma, and real gamma means it will be constant for the given liquid we will take. Everybody got? So relation between gamma real and gamma container. Anybody know what is the relation between gamma real and gamma container? Relation between gamma real and gamma container. Relation between gamma real and gamma container. Anybody know? Delta V observed upon delta, don't know. Okay, so listen. in maybe somebody has read that relation, or you learned this relation, gamma real is the gamma apparent plus gamma container. But one thing, that relation, if you know, so this relation by default in the books they are not mentioning, and sometimes we are getting confused with when I have to use this relation, and sometimes we are predicting the answer wrong also. So that relation, if you have learned gamma real is equal to gamma apparent plus gamma container, that is only applicable when the container is completely filled. So if they not mention we have to use the relation between gamma real, gamma apparent, then by default we have to assume what? Container is completely filled. Container is completely filled. So here I am writing what? If container is completely filled, if container is completely filled, okay, then easily we can derive also, like container completely filled, then delta V of the real is equal to delta V of the container plus delta V of the delta V apparent. Okay, like 9 is the actual expansion of the liquid, 9 is the actual expansion, 9 is equal to what? 5 is the expansion of the container plus 4 is the apparent expansion. Okay, like mathematically we can derive also easily. So directly I am writing the relation. If container is completely filled, then gamma real is the gamma apparent plus gamma container. This relation you have to remember, gamma real is equal to gamma apparent plus gamma container. Completed? Okay, container is solid. Container is solid. Arey yaar, how many of you want how? If more people want how, then I will explain. Who needs the explanation of this? Okay, I want 1%. Only 1% want. Okay, in short, I am saying fast. So suppose what I said, that's why I said this relation is only applicable when the container is completely filled. One is saying no. Okay, so suppose container real expansion means what I will say, delta V liquid real is equal to what? Liquid expand some. Okay, some is required, what some container will expand and some liquid will expand. What we will observe, that is apparent. Okay, so real expansion, I can say change in volume of the liquid is equal to what? Delta V container, how much container expand, whatever extra is there that will come out, or the due to that level will fall, so plus delta V apparent, delta V apparent. Okay, so real expansion of the liquid, what is the actual expansion in the liquid, that we will say what? Delta V container plus delta V apparent. This relation everybody got? Okay, now delta V, what is the formula? V initial into gamma into delta theta. Okay, what I said, container is completely filled, then I will take initial volume of liquid Vi into gamma real into delta theta is equal to container volume and initial volume of the liquid, both are same. That's why I said by default this formula is applicable when container is completely filled with liquid. So container volume also I will take what? Vi into gamma container into delta theta plus delta V apparent, what I will say, initial volume into gamma apparent into delta theta. Now you can see delta theta Vi, delta theta Vi, delta theta Vi cancel out, gamma real is equal to what? Gamma apparent plus gamma container. Understood or not? Tell fast. That's why I said by default they are giving this relation directly, but this relation I can only write when the container is completely filled. If the container is not filled, then what will happen? Here suppose I am taking liquid and it is only half filled, so here I will take Vi by 2. Then here I will take Vi by 2. Here I will take Vi. This relation will not be valid. Okay. Next thing, Completed. And container is solid, so for the container what we can say, gamma and alpha relation is what? Gamma is equal to 3 alpha. Then gamma real what I can say, gamma apparent plus 3 alpha container. Because container is solid, for container I can use the relation gamma is equal to 3 alpha. Completed. Okay. Now suppose I am saying in the liquid gamma real is greater than gamma container. On in which container I am taking and which liquid I am taking. Suppose I am saying the gamma real is greater than gamma container. So on increasing the temperature, on increasing the temperature, who will say liquid will overflow or the level will fall? Liquid will overflow or the level will fall? Liquid will overflow or the level will fall? Overflow. Why? Liquid expand more than the container. It means mathematically also, if you see, gamma real is equal to gamma apparent plus gamma container. So gamma real more, it means it will come what? Gamma apparent is greater than 0, or we can say positive. Gamma apparent is positive means what we will say, on increasing the temperature liquid expanded. So when gamma real liquid expand more than the container, then overflow will be there. Then what explanation we will give? On heating the liquid expanded. That's why it is overflowing. Then for us, what is a gamma apparent? We will say the gamma apparent is positive, or gamma apparent is greater than 0. Everybody got or not? So if liquid gamma is more than the container gamma, then gamma apparent will come positive. Completed? Okay. Number 2. If I am saying gamma real is equal to gamma container, means liquid expansion coefficient and the container expansion coefficient are equal, then what will happen? On increasing temperature, what will happen? Tell fast. Then on increasing temperature, what will happen? No change, means level remain same. So no change or level remain or container remain completely filled. Then what you will say about gamma apparent? Real expansion of the liquid and the container expansion gamma are equal. It means gamma apparent I will get 0. Gamma apparent is 0. Then what I will say? There is a no change in the, because we are not observing any change in the volume. So what we will say? There is a no effect of temperature on the liquid. It means what I will say? What gamma apparent is equal to 0. Okay, because we are not observing any change in the volume of the liquid. Okay. And number 3, if gamma real is less than gamma container, means liquid expand less than the container, what will happen? Liquid expand less than the container, what will happen? level will fall. Why? Container expand more, liquid expand less, then level will fall. Not water level, liquid level. Then liquid level fall. Or we will say what? Gamma apparent is less than 0 or gamma apparent is negative. Then why we will say negative? Because on increasing the temperature, volume is decreasing. Because what we are observing earlier, it was completely filled. Now after heating, the level has fall. Level has fall. It means what we will say, on increasing the temperature, liquid volume is decreasing. So explanation what we will give, gamma of the liquid is negative. So we will say gamma apparent is negative. Completed? Okay. First, you will say liquid will over, suppose any container of capacity 1000 ml, it is completely filled with liquid, and on increasing the temperature by 100 degrees C. First, who will say liquid will overflow or the level will fall? Liquid overflow or the level will fall? Tell fast. Liquid overflow or the level will fall? Liquid will overflow or the level will fall? Overflow. Why? Because gamma, we can say here gamma liquid is more than gamma container. Why? Because here power is different. If after making the power same, you can easily compare. Like here power 4 I gave, so this I can say what? 40 into 10 to the power minus 5 per degree C. Now 46, which is more? Gamma liquid is more than gamma container. Then liquid will overflow. Okay. This everybody got? So it means liquid will overflow. Up to this okay? Now suppose I am saying second part, volume of liquid overflown. How much volume will come out? Tell fast. How much liquid will come out? So what I said, like suppose I said liquid expanded by 9 ml, container expand by 5 ml, then how much liquid came out? 4 ml. Okay. So it means first I will find how much liquid expansion is there, real expansion is there, then how much container expansion is there, and difference will come out. By the gamma apparent formula also we can use, but I am going to the this method. First I will find delta V liquid. So delta V liquid is what? V initial. What is the V initial? 1000 into gamma of the liquid. Gamma of the liquid I gave what? 40 I think, no? 40 into 10 to the power minus 5. That is 40 into 10 to the power minus 5. Vi gamma delta theta is what? 100 degrees C. Now 1, 2, 3, 4, 5 cancel out. So then 10 to the power 5 cancel out. So this what we got? 40 ml. So what is the expansion of the liquid? 40 ml. Now similarly I will calculate the delta V container. Delta V container is equal to what? Same 1000 initial volume. Gamma of the container I gave 6 into 10 to the power minus 5, and that only na 6 into 10 to the power minus 5, and delta theta is what? 100. Now 1, 2, 3, 4, 5 cancel out. How much we got? 6 ml. Means container expanded by 6 ml and the liquid expanded by 40 ml. Who is saying 4 ml. 4 ml or 40 ml? 100 ml given or 1000 ml given initial? 1000 given, na? Any data problem? Okay, correct only. Then now volume of liquid overflow. Volume of liquid overflow. That will be equal to what? Delta V liquid minus delta V container. That is equal to what? 40 minus 6. It is equal to what? 34 ml. So how much liquid will come out? 34 ml. Everybody understood? Okay. Okay. This we can use by this we can find by using the gamma apparent formula also. Gamma apparent is equal to the gamma real minus gamma container. Then that you will multiply with volume of the liquid into delta theta. Then also you will get directly 34 ml. Okay. Completed. So you can try some question by own. 1-2 more question I will discuss. That is based on the density and this gamma real gamma apparent. Okay. Next class. Any other doubt anybody has? Up to this, anybody has any doubt? Bye then. Bye.